Well, welcome to my talk. Thank you so much for being here. It's wonderful to be back at All Things AI, and we have a packed room. It sounds like a lot of people are very excited to hear about agents and agentic development. So how many people here in the room have developed agentic POCs in the last 6 months? Lots and lots of hands. That's great. Okay. And now, how many people do we still have today running those agents in production? I see 2 hands, 3. Okay, that's a big difference. So what happened? Things move, right? Things change so fast. There's so many new tools, new technologies, a lot of business requirements. Things move really quickly and change in this space. So how do we build so we can enable our teams to make it fast, secure, scalable, and also build within the guardrails of our laws and regulations? So the first thing we're going to talk about today is why is it so difficult to build these systems in a scalable and secure way? I work with many customers across different regulated industries, healthcare, financial services, utilities. These are all very highly regulated. They have a lot of different rules they need to follow. And what I hear from a lot of these customers is there's immediately at least 6 different requirements as soon as you want to try to take something to production. First of those things is performance. Performance can mean different things to different people. It's surprisingly nuanced. One of those things is accuracy. You actually want your agents to return accurate answers. They want them to be factually correct. You want them to be complete. You want them to be relevant. You don't want your agent to be giving out information that doesn't make sense. You want them to be helpful. So there's a lot of different dimensions there. And as you scale and your agent needs to support thousands of users, tens of thousands of users, you want to make sure that you can maintain that trust and accuracy as you scale. You don't want to be losing that trust. That can mean big problems for your business. As you scale, it also implies that there are some security implications. How do you make sure that the different information that is being passed around that's potentially very sensitive, PHI, PII, social security numbers, how does it not leak between different sessions within your agent? That's very important. We're going to talk about that today. Security is one of the biggest concerns for our customers. Also, not on this slide, but as you scale and you need to scale securely, there's also memory, right? How do you make sure your agents are actually useful, that they're not cold to our users, that they remember what our users are saying? They remember what they said 5 minutes ago, 5 months ago. You don't want to keep repeating yourself. Otherwise, it's not very useful. It's kind of boring to interact with an agent that doesn't remember what you said 5 minutes ago. There's also a big aspect of monitoring your agent. You need observability. Your legal is going to come in. Your compliance is going to come in. What are you going to tell your security officers about how your agent is performing? You need to make sure you have observability at every step of the execution. We're going to talk about that. And lastly, some governance. You want to make sure that your agents are actually doing what they're supposed to do. How do you evaluate them in production? We're going to touch upon all of these things today. And many of our customers, as they start building, they feel like they get started. They build great prototypes, and then they get into this situations where they don't really know what to do. They are stuck for a quarter or more trying to get things to production, and that can be very frustrating for them. So this talk is about us talking about some managed infrastructure that AWS provides to make this process easier for you. We're going to talk about Bedrock Agent Core, which is a modular and managed infrastructure platform for you to build agents. You can pick and choose the different components that fit your use case best. I will cover the different components to the best of my ability in the time I have allotted. I will give you some resources to get started. And you can then choose the components that best suit your use case. And if you have any questions, please, I will answer them after the talk if I don't have time, and I will be glad to elaborate. But let's get started. So the first thing that is a very actionable problem here that we need to solve is where are you going to host your agent when you get started? You can't host it on your laptop. That's where you get started. And as you begin scaling, developers start asking themselves questions. I have many users. I need to be able to scale securely. I have my security officer coming to me and saying that this thing needs to be secure. Better be secure and handled by PHI. It can't be leaking between sessions. So how does that work? And most of us developers here who have at least built the POC, I'm sure they've worked with their platform teams as well. Most of us have that in our organizations too. And they think across more than just one agent, right? They're probably thinking about the thousands of use cases that your business already has lined up. They can't keep up with it. Different teams have different frameworks that they're using. Some people are using Claude SDK. Some people are using Strands, LangChain. They're using different observability tools. It's a bit of a mess. So how do we control all that? How do we enable our builders to use the tools that they want to use and also do so securely and within some manageable guardrails? So let's first talk about the core component that Agent Core provides. That's runtime. That's the first thing that most people will use and will choose to use, and for the reasons that I'm about to tell you about. Agent Core Runtime is a place for your agent to live and run. It is very flexible and allows for your agent developers to use any development framework of their choice, or no framework at all if they don't want to use one. They can use LangChain, Strands, Crew AI, and they can use any protocol that they want to use. It supports MCP protocol for tool interactions. Or it can also interact with agents through the A2A protocol. You can also use any inference provider of your choice. You can use models on Amazon Bedrock, many models to choose there on Bedrock. You can also use Gemini, Claude, etc. You can have the choice of any model you want. And it is secure and scalable, and it removes a lot of heavy lifting from your developers, because this is something that comes out of the box. Now, and it really is any framework that you want. You can build multi-agent systems, for example, and you can have multiple agents interacting. And all of those agents can have different frameworks that support them. You can have, again, Claude SDK, you can have LangGraph, Crew AI, and be orchestrated by Strands, for example. That's not a problem at all. And you can also pop your tools into the runtime as well and interact with them through MCP. So all of this is possible through runtime. It's very powerful. Now, I'd like to note that it is built on Firecracker. Firecracker is a micro VM hypervisor that AWS released at reInvent 2018. It's a very powerful piece of technology that backs AWS Lambda, DSQL, and many of our other analytics tools. It's been chosen here for Agent Core Runtime for its reputation for security, scalability, stability, and performance. Why is that really interesting here for us? It's very interesting because it is a true virtual machine. It provides secure boundaries for your agents to run. They're completely isolated in a virtual machine. They're strongly isolated. They have their own compute resources, their own memory resources and file system. You don't have to worry about information leaking between your systems. For example, here you might have users passing around very sensitive information. You don't have to worry about it leaking. No prompt injection. Nothing is going to leak between those boundaries. When that VM is done executing, it just goes down. That's it. That's very interesting to us, because it is the model that runtime uses is a dedicated VM per session. So you don't have to worry about these things like permission escalation, prompt injection, etc. So when the session is done executing, it just goes away. That's it. That's really, really powerful for our developers, because it enables them to write much simpler code. They don't have to worry about writing code that handles multi-tenancy or multi-threading. It can be very simple. The code can be single user, single session, and they don't have to worry about clearing memory, clearing variables, temporary files. It just goes away. That's it. And that enables them to remove a lot of heavy lifting and get started quickly. Now, another thing I'd like to mention about Agent Core is its pricing model, which is also very compelling for our developers. Unlike Lambda, Agent Core Runtime is priced per busy time. So that means when your agent is running, as it's going through its interactions, as you can see here, you might be interacting with your agent at multiple times. And at a certain point, it will get back to you and say, I need more input to proceed, whether it needs a human to get back to it, another tool, another agent, and it's waiting a lot. So while that's happening, you're only going to be charged for the memory. You're not going to be charged for the compute, which on average can reduce the price of this runtime by around 20 times, which is really great and very powerful. So that's the first piece of Agent Core that I would like to talk about, this runtime. Next, what do we need for our agents to be useful? Memory. We want our agents to remember things. We don't want our agents to be getting back to us in 5 minutes and asking us for something that we already said. That's kind of annoying and not very useful. So how do we do that? As I said, Agent Core runtime is a micro VM that spins up in milliseconds, but also then goes away after the session is completed. So Agent Core provides a memory component for you to be able to do that, to store your memory outside of the session securely. It is encrypted at rest and in transit and allows you to store short-term memory through the conversation that your agent is having. Through this conversation, the events get recorded, so as your user is interacting, it's able to remember things. What's more exciting is that you also have automatic memory extraction from those conversations that happen in the background. It's a process that you just set up. You don't have to do too much. It's very easy. And the process will be extracting information as the interactions go on. It will be able to do summaries, extract facts, save user preferences. So as the interactions go on with your agent, it's going to be able to, the user will be able to come back to your agent months from now and still remember preferences that it has set. And that makes our agents much more interesting to interact with. They become hyper-personalized. They become not as cold to our users. And again, it plugs into any framework that your developers may want to use. And that makes it, again, much easier for our developers to get started. It removes a lot of heavy lifting. Now, aside from memory, what else does Agent Core provide us? Agents by themselves may not be super useful in and of itself. They may chat with our users like a chat bot, right? But what really makes agents interesting and powerful is the fact that they can use tools. They can interact with an external environment. They can make changes. They can interact with our data, right? They can make some kind of downstream effects on our environment. That's what makes agents truly powerful. And you don't want agents to be just using any random tools and data. You want your data. You want your enterprise data. That's what makes these agents really, really important to your organization. So you may have this data accessible through APIs, microservices. You might have data in databases, object storage. You might have some kind of SaaS solutions or internal applications. So how do agents do this? Tools is what make agents useful, but in order to access those tools, we need something that centralizes this access. Agent Core provides what is called a gateway. The gateway allows our tools to be presented to our agents developers in an organized way, in a way that you can also audit, monitor, and control. That component is called Agent Core Gateway. Through the gateway, you can easily plug in your tools, your APIs, microservices, your existing databases, etc. You can wrap them through an interface that your agent can understand, and you can give them to your developer and say, here, use this. This is what you need for your application. And you can have many of these gateways. It's very useful to think about this in a logical separation. If you have many business units building different applications, you might give a gateway to a developer that's working on a particular application so they have context for what kind of tools they're using. And you can wrap security and access controls around that gateway. In terms of what kind of things you can integrate and how, it's a little bit of a busy diagram. But the idea is you can expose tools through different kinds of endpoints. You can have endpoints for APIs, you can have endpoints for MCP servers, different models, etc. And that gives your developers choices for what they want to use. So it's very flexible. Now, as you think about this, at first you might think that there's a shortage of tools in your environment. But one thing we often see is as developers keep building and more tools are available in your enterprise, you might actually get into the opposite problem. You might be having hundreds of tools available, thousands of tools. And one common anti-pattern we see is that you give the developer a gateway with thousands of tools. And the agent is choosing from these thousands of tools. Now, if you're a person and you're given a toolbox with 1,000 tools and asked to choose a tool out of these thousands of tools based on a tiny label on the tool, how would you feel about that? Not very good. It doesn't make your agent very cost effective. There's too much metadata being passed into the context. It's slower, it's less effective that way. So the Agent Core Gateway automatically indexes these tools. It provides a semantic search feature, which helps it return the most relevant tools for the context your developers are working with. It's very powerful. That way your agents can be more cost effective as they select the tools they need to work with. The next thing that's very powerful here with the gateway is something that is built into the gateway. How do we control these tools? This is where policy comes in. Bedrock Agent Core Policy is a thin layer built into the gateway that allows you with very precise mathematical statements to tell your agents what they're allowed to do. When you think of agents being secure, you can think of what they can say, and that's when I think about things like Bedrock guardrails, or guardrails in general. Things like them not being biased, not talking about topics they're not supposed to talk about, not using specific words or verbiage. When you think about things that agents can do, that's when you think about policy. That's authorization, things that they're allowed to execute. Policy here with Gateway is built with Cedar. Cedar is a policy language that is designed to be very expressive and very powerful, declarative, very easy to understand. Something that is with very fine-grained control, can say what your agents are allowed to do. Here's a simple example. It specifies which principal can do specific actions on a resource and under what conditions. So here specifically you have an OAuth user that can do something, interact with the gateway. Why is this interesting? This is important to understand because you can do certain things in policy that is outside of your agent code. It is outside of your tools, and it's outside of your downstream systems. Here's a slightly more interesting example where an OAuth user is accessing a weather service. I don't know how many of us need to access weather services in an enterprise, but it's just an example, right? The idea is you can specify fine-grained conditions in your policy that are, again, outside your tools, outside of your agents, so regardless of any prompt injection or manipulation that is happening in your agent or prompts, it'll never be able to do anything outside of the scope that's specified in your policy. So you can still make your policy enforceable with specific rules outside of your agent. And you can have then policy be reviewed by your security team. You can monitor those and audit them. And that's very nice. Now, the way I think about it conceptually, it's kind of like this. If you have business applications, they might have multiple agents composing them. For example, on the top, there's 2 agents with a gateway and a policy, and on the bottom, we have just 1 agent with a memory. Policy is on a direct path out from your gateway. So anything that your agent does, anything that it interacts with, will necessarily go through policy. So you can enforce very fine-grained control through policy. That's why policy is so powerful. Now, do we still have time? We do. 334. Look at that. Aside from these core pieces that Agent Core provides, there's a couple of other useful tools that it has, a couple of useful services. Again, Bedrock Agent Core is composable. It's modular. You can choose any one of these components that you want. I see some customers using more, some customers using less. It's completely up to you, what you found useful. Aside from the ones we already discussed, there's also a couple of other tools that are maybe a little bit more niche for specific use cases. Code Interpreter, Agent Core Code Interpreter, what's that? As we evolve our agents, they interact with models, right? And something that models do is they generate code now for doing analytics, running long-running processes, analyzing data, because models themselves may not be very good at complex math, right? We don't want them doing complex math necessarily, maybe simple things. And when they're doing this complex math or processes, you would want that to run kind of more confined, because you don't trust that code, right? This is not the code that you wrote. You didn't test that code. So to prevent that from doing anything to your agent itself, this is where Code Interpreter comes in. You hook it up to your runtime, you hook it up to your agent, and it is essentially able to execute that code that the model generates outside of your agent. So if anything goes wrong, it's separate, it's confined there. But you run it, you get the result back, and that's it. So you can use it for long-running processes, analytical workflows, etc. And it's really nice because it comes with a lot of pre-built runtimes that you may want to have, like Python, JavaScript, TypeScript, and many different tools for data analysis, like Pandas, Scikit-learn, NumPy, etc. Otherwise, you would have to maintain and install a lot of that stuff yourself. Here it's nice because it comes built in. Another tool that's useful is a browser, Agent Core browser. Now we're building agents here, right? The enterprise is interested in new agentic workflows. But likely, you still have a lot of legacy systems, right? Some of them are 5 years old, some of them are 25 years old. You're not going to reinvent those just to build an agent, right? You need to do something with that. You still need to get data out of there, or somehow interact with it. This is where Agent Core Browser comes in. It is a headless browser that you can hook up and use in your agentic workflows. And it can then interact through the browser with your systems. You can scroll up and down, fill up forms, copy and paste from forms to other different fields, etc. And all of that is monitored, right? You can then record all of the actions that were taken there. All of this is being audited and recorded, which is great because you can then monitor what happened. LLMs are very good at analyzing screenshots these days, so this is also a very powerful capability. Now, a couple of other cross-cutting concerns here for our agents. And I'm going to try to get through those fairly quickly so we can take some questions. Identity, right? All of this is happening. You have users interacting with agents that may be interacting with other agents that are interacting with your live systems and data. This better be secure. You want to make sure that this is not giving access to individuals or autonomous agents that it shouldn't have access to. So identity is the component that makes that happen. This component is built into runtime and gateway, and it integrates with inbound and outbound auth. On the inbound side, you can integrate to any identity provider of your choice that you're using. Some people might be using Microsoft Entra ID, Cognito, Okta, the Auth0, others. You can integrate with that, and then you don't have to be copying your users anywhere or reinventing the wheel. It's very powerful on the inbound auth. On the outbound auth, you want to make sure that your incoming users through this agent can do actions in your downstream systems. You may have internal systems like Salesforce, Workday, etc. And you want to make sure that the credential providers, whatever their authorization model is taken into account. So you integrate that into your identity as well, so you can propagate that, and the users that are supposed to have appropriate access are able to do that. So the agent autonomously or the user, or the agent on behalf of the user is able to gain access. So it takes care of standard OAuth flows. It can deal with API keys And even for certain scenarios dealing with AWS resources, it integrates with IAM roles as well. It has a built-in vault into the identity, into Agent Core identity. So it takes care of some common flows for your user, like token refreshes, etc. So your end user doesn't have to be overwhelmed with reauthorizations and things like that. Now, the next concern that's cross-cutting for these applications is observability, right? We talked a lot about all of these different tools. Now, how do you make sure that you can then go in and take a look at this? You can make sure that things are happening in the right way. Again, your legal is going to come in. You're going to need to tell them that this is happening properly. Compliance is going to come in. How do you verify and show them the evidence? Where's the evidence? Observability is an out-of-the-box service with Agent Core that plugs into all the other services that you see here. Again, it works with any runtime, any framework. Very easy to enable. You just go in and select which agent you want to enable it for, where your traces are coming from. It's going to capture traces, logs. And you select a sampling rate. And any kind of traffic that's coming through your agent is going to show up. It natively integrates with CloudWatch, and it shows you a lot of the standard metrics that you want to see, like error rates, latency, token count, session duration, etc. But also you can build out some custom metrics that matter to your business as well. You can do that too. And it gives you some actual deep dive availability through a visual interface where you see each loop of your agent interaction. What tools were called, what parameters were passed to the tool, what did it get back, maybe there was an error, how did it pivot, etc. So all of those things you can see turn-by-turn interaction through observability. And of course, there is open telemetry integration, so any kind of your own observability tool that you want to use, anything OTel compatible, Dynatrace, Datadog, Langsmith, all of those are available as well. And finally, probably most importantly, is how do we know that these agents are actually doing what they're supposed to do? Are they actually meeting the business goals, what your user wants them to do? They need to be evaluated continuously. Again, as we talked at the beginning, performance can mean very different things. It's very nuanced for different use cases. Might be, is it polite? Is it helpful to the user? Is it using the right tools? How is it selecting those tools? How is it choosing parameters? If you can't answer those questions, you're not doing a good enough job doing observability in production. It's very important. These are compliant workloads we're talking about. You're going to need to be able to supply evidence. So feedback is very important. How do you evaluate feedback to make sure you're both secure compliant, but also if you want to make changes to your agents? If you want to evaluate a different model, if you want a bigger model, a smaller model, how are you doing on costs? Things like that. Feedback is very important. This is where evaluations come in. Evaluations are pre-built metrics, 13 pre-built evaluators that you can easily enable for your agents, that you can configure, that evaluate as your agent is executing online in production with real users and real data. You can also do it on demand before you're in production, yes, but the most valuable is as you are there running it. And you can configure them very quickly through an interface, and then you can see and monitor the performance of this so you can make appropriate changes. And some of these things for evaluations are, like I said, maybe correctness, goal success rate, tool selection, etc. And you can also define your own. So these are the building blocks that we talked about for Amazon Bedrock Agent Core. We talked about the runtime where your agents live, memory that make them remember things, gateway where you organize your tools, identity, policy that enforce security and authorization. We talked about browser code interpreter, and observability and evaluations. These are tools that you can select from. These are all available. But again, different use cases may or may not need all of these. It's up to you, which is the power of this platform that allows you to build these agents, allowing you to scale, but also allowing our builders flexibility to use the different open source tools that they want at any time. So the key takeaways from here is you want to get to production. Production is important. Your business is not going to extract value from your use case unless you're in production. If you're using managed services, it can accelerate your journey to production. This is where Bedrock Agent Core can help. You want to know what your agents are up to at all times, which is why observability and evaluations are so important and key to Bedrock Agent Core. Security obviously is fundamental, and that's why it's such a big cornerstone here with identity and policy. And lastly, the point of this modular platform is, again, to accelerate your journey to production. So to help you get started, there's a couple of resources that you might want to take a look at. Documentation for Amazon Bedrock Agent Core, some code samples. You can take a look at that, take it back to your organization, and learn how you too can accelerate your journey to production with your agents. Oh, if we want to take more pictures, we can do that. That's all I've got. I know I'm up on time.